So we can say we have this necessary condition if we rule out these exceptions. I'll say necessary condition. So if the optimal choice involves consumption of both goods, involves consuming both goods, and we rule out kinky tastes or kinky preferences, kinky preferences. So those two exceptions that we talked about before. So if we rule those out, then the indifference curve will be tangent to the budget line. To the budget line. We rule out those exceptions, then we have that tangency rule. But is this sufficient? So it's necessary, but is it sufficient? I.e., like if we know that we have a tangency line, does that make it the optimal? Right? That's what we're trying to say. If we find a bundle where the indifference curve is tangent to the budget line, can we be sure that it is the optimal bundle? So that's what we want to ask next. Optimal bundle. So it's a necessary condition. If we eliminate the corner solutions and these kinky preferences where the tangency is undefined, then the optimal choice will be, there'll be a tangency between the difference curve and this budget line. But if we find a bundle that's tangent, that they have this tangency condition, does that mean it's the optimal? That would be a sufficient condition. And that's actually not the case unless we make a bit more, another assumption, or we limit ourselves a bit more. So let's talk about that. So let's kind of just draw out an example, and we'll do a little bit of writing over here. Hopefully we'll have room. Sum out of x of good 2. Let's not make this as long. Amount of x1, just want to give us as much space as possible over there. Let's say this is our budget line here. And let's say we have preferences that kind of look a little bit weird like this. And then we have another indifference curve that kind of looks like that. And I guess I should be a bit more careful with these. But let's have them kind of go off this way. Okay, so notice that, maybe it's not a perfect drawing, but we kind of have 3 points here. There's 1 point there, let's pretend that point touches, and that point touches. Well, here we have tangency at all 3 points. Tangency at 3 points. Maybe we can call them, x, y, and z. It's, we're only maximizing our utility, or we're only on the highest indifference curve at points x and z. So only optimal at x and z. But it's also, we have this tangency also at y. So in general, this condition, this tangency condition, is kind of necessary, but it's not sufficient. In general, this tangency condition is necessary. If you rule out boundary conditions or corner solutions and kind of these kinky preferences, it's a necessary condition, but not sufficient. So you can have a case like this, where these aren't this isn't a corner solution, and these preferences are kinky. But here, y is we have this tangency condition, but it's not the optimal choice because they could be in a higher indifference curve by having x or z here. It is sufficient when we have convex preferences. That is, any point if we had convex preferences, any point with this tangency is the optimal point. Is optimal. So if we impose this other constraint that preferences are convex, then it becomes a sufficient condition. If we find a point with this tangency, then it is the optimal. If we don't make that assumption that preferences are convex, then we could have cases like this where this condition of tangency is necessary but not sufficient. And if we had strictly convex, then we can rule out certain cases, and we just basically have like a unique optimal bundle. So there's not multiple optimal bundles. Like here, we have strictly convex preferences. But now let's move on and kind of discuss like more intuitively what is happening with this tangency point. What does this tangency mean economically? So it's like the market is offering a certain exchange rate. They're offering an exchange rate of the slope of the budget line, those price ratios. So the market is offering a rate of exchange of minus P1 over P2, or like the slope of that budget constraint, right? So this means if you give up 1 unit of good 1, you get P1 over P2 units of good 2. Remember, that's what the slope is capturing. So basically what this is saying is if the consumer is at this optimal bundle, if consumer is at x1 star, x2 star, so the star is indicating the optimal choices, then they are just willing to stay with current bundle given the price ratio. Given the prices, I'll say. Given, I mean, two does there, but given the prices. And so remember, that's the point where this marginal rate of substitution equals this price ratio. This is the slope of the indifference curve, and this is the slope of the budget constraint. And so remember, we kind of talked about that marginal rate of substitution, that idea of how to interpret it. It's like that, we were offering this exchange rate E, and we left that exchange rate very general, and basically it was the exchange rate where the person was just willing to not trade anything. Well, that's exactly what's happening here. basically the market now is offering this exchange rate of the price ratio. And the consumer is just willing to stay put. They don't want to trade some of good one to get more of good two at this point. So they kind of maximized their utility in the sense that they're on the highest indifference curve possible. They don't want to change how much they're consuming of each good unless like income or price has changed.